Hi, I'm Empty. I'm going to be doing a quick breakdown on the visuals in Stasis Break. A lot of people were asking how I did certain things like the time reverse visuals, the particle effects, and the pixel art sprites that are used in the game. So this is just going to be a quick-ish breakdown video on how I kind of set everything up, what my workflow was. Yeah, so let's get started. First, I'm going to do a quick demo of the game, just to show you which effects we'll be talking about. So in Stasis Break, it's a shmup. You fly around, you shoot enemies, and whenever you choose, you can press a button and you can go back in time, like so. So the effects I will be breaking down are the particle effects, the pixel art kind of look to the game, and of course the time reversal. So let's jump straight into that. So starting with the pixelized rendering, I set up a simple orthographic camera. So it's orthographic to make everything look flat. There's no perspective, there's no small things in the distance, and just to, you know, kind of keep things looking flat and sprite-like. If we look at perspective, we see things look a little different. It's kind of hard to tell, but it does take away from the effect. So orthographic is important. The next thing I do is I output to a camera texture, a render texture. And this render texture is going to be at a very low resolution. I went 240 by 320. The reason I did those numbers specifically was I just eyeballed it until I got the ship looking kind of the resolution I wanted. I wanted the ship to be, you know, about 4 pixels on the cockpit, about 2 pixels on these little wingtips. So, yeah, I set the resolution to be a small number. The next thing that's important is anti-aliasing has to be turned off completely. If we turn anti-aliasing on, we get this blurred muddiness along the edges as the anti-aliasing does its job and smooths the image. We don't want the image to be smooth, we're doing pixel art. If we set it to be no filtering, we get these nice crisp edges, and we keep the kind of the poppiness, the brightness of the colors, because they don't blend together. I'll just show that again. You see the purple is blending into the blue, the purple is blending into the gray, the purple is blending into the black of the background, and in all these cases we're kind of losing the vibrancy of the color. It's especially an issue in these smaller resolutions with these small sprites, so that's why we turn it off. The next thing is the filtering. I set it to point rather than bilinear or trilinear, because as you can see in bilinear it kind of automatically smooths the texture and makes it blurry. This is actually a more realistic look for a CRT or a low resolution monitor, where those pixels would actually in real life kind of blur together. But the accepted convention for pixel art is that edges have to be sharp, and I personally kind of agree with that. I actually like the sharpness on the textures. I think they look good. So that's what we do. We just simply leave it as point, keeps these hard edges on everything and makes everything look super crisp, which is what we're after. And so that's the pixel art system. It's really quite simple. Especially when you consider it, like, it's just rendering these horrible little game jam models. It's primitives and spheres. It's nothing special. But when we render it through that, they look like sprites. A small trick I used to kind of reinforce this look of them being sprites is everything's kind of limited. So animations, if we look at this animation on the hourglass, we'll see that it's low frame rate, and that's to, you know, give that illusion that it only has four frames in its animation. The player character, when he moves to the left and the right, he tilts, and I had made sure to only tilt in increments of about 10 degrees, so it actually looks like there's less sprites there as well. It kind of jitters, and the enemies do the same thing. As they turn, it's easier to just demo that. As the enemies turn, they're locked to units of 15 degrees, I believe, just to make it look like they're on a sprite sheet. And it's more evident on a big guy. We'll just wait for one of them to pop up. There's one. So you can see that he's kind of rotating in this really stiff, limited way, as though he'd been hand-drawn on a sprite sheet. So that's kind of how I mimicked a kind of classic retro pixel art shmup look. The next thing is the grid. The grid does two things. it's kind of visual interest to keep the player entertained, not looking at just a blank screen when there's no enemies on screen. And it also provides context. It's constantly scrolling, which makes you feel like you're moving through space. There's a parallax, which makes you feel like you're moving fast because it's supposedly in the distance. And it's pulsing lightly with the music. It's kind of a subtle effect. You may not have 100% noticed it, but with the music you can see it kind of pulses just a little bit, and that's again just to keep it visually stimulating, so it's not completely boring when nothing's happening on screen. So the scroll and the audio effect are quite simple. The scroll, we simply use set texture offset. We're changing the texture offset on the main texture, and we simply pass in a new vector 2, which is just a vector saying how far to offset it on the material. You can pass in any variable here. I use my own special world time so I can reverse it. It's just basically time.time. If you know what that is, time.time. It's basically the same as that. I've just done it this way so I can reverse it when time's going backwards. So if we look at the material, we'll see main text is this albedo for this one, and main text is the Unity standard for the default texture on all of their shaders. When you write your own shader, you can call them whatever you want, but Unity always calls it main text, so it's a pretty safe one to do. And the offset is simply that. It just offsets the texture and it tiles forever. And that's a really simple way to get a nice, cheap, easy, infinitely scrolling background. The next thing is the audio pulsing. Again, really simple. We do audio listener.get spectrum data. This is a nice little function call that gets you kind of the wavelength of the currently playing audio on that frame. So it's going to output this big list of floats. And those list of floats are essentially, now this is just a Google image, this is just to give you an idea, but essentially this type of thing. It's just a big list of what frequencies are currently being played through the speakers. And so you can look at that and you can do all sorts of fancy magical mathematical things on this. If you're a sound engineer, you can do amazing things with this spectrum data. I'm not really a sound engineer, so I just take the average to get a rough approximation for the volume. I don't think that's actually what the volume is, tangentially. I think the volume is probably like, you have to do some crazy math log stuff and like all sorts of mathematics to calculate the real decibel volume, but I don't care about that. I just want a rough guesstimation of how loud the current spectrum is, and all I do is I just average all of those floats in the spectrum. And all I'm doing with that average is I'm just setting the color, basically. I use a gradient, but you can do whatever you want with this number at the end of the day. And I just kind of lerp between a dark and a brighter color. And that's how the background grid works. The other thing is the particle systems. These are really simple in this game. There's nothing special about them. Because it's a jam game, I didn't want to spend too long making textures and sprites. So literally pretty much everything's just a circle that I made. And when we move this into the renderer, we see it looks quite nice with the pixel renderer. It looks very retro. It's very cool. I try to use flat colors. It's mostly additive. Nothing special going on here. Very simple particle effects. Finally, let's talk about the time reversal effect. So just another quick refresher. As we go back in time, I'll just blow some stuff up so something happens. So we reverse time and everything kind of gets a trail. You see on the enemies there's a trail. On my clone there's a trail. And everything kind of changes color and looks really trippy. So the way that works, if you've ever played a 90 FPS and you've fallen out of the map, you'll know exactly what's happening. So I'll just turn the background off and we'll see the raw kind of effect that I based all this off. So you can see everything is kind of glitching out and leaving a trail. And what this is on the camera, I've set the clear flags from the usual solid color, which fills it with a solid color, to depth only. And what this does, I'll just get the visual up again. When we clear only the depth flags, that means all the color data in the scene from the last frame is still there the next frame. So whatever we drew last frame, the models, the particle effects, the grid, the background, anything that was on screen, will be kind of kept as an image, and then the next frame we draw on top of that. And so we get this utter chaos. So to kind of mitigate the chaos, turn the background back on, and I'll lower the alpha. So to mitigate this chaos and get a nicer looking trail effect, I have this background. It's just a big mesh, and it's a dark color, and has a really low alpha, 7 in this case. You know, you can, there's different amounts you can do, and the more alpha, the shorter the trails will be, but we'll just go with like 7 or 9, 14, that'll do. And you see that with this kind of really low opacity, we get a nice little trail. And so the reason, let's just pull that up again. There we go. So the reason this looks a bit nicer is because each of those frames that we previously rendered, before we do the new frame, the bottom layer is just a really low opacity dark texture, and that's just going to slowly fade out more and more over time. The older frames are going to kind of fade to black and fade into nothing. So that's the core trick that's used. To make it a bit fancier, I have this time warp colorize script, and basically all this does is we have a gradient that defines a bunch of different colors, and the longer you're in the time warp, the deeper we move along this gradient and sample a different color. So to start with, when we're not in a time warp, we're at this dark color and full opacity, so we lose the trail effect, and you should see that now. There we go. So, you know, everything looks good. And as we go back in time, we're kind of sampling from this. So we're sampling around here, I think now, because we've been in this. It's just simply a variable increments the longer you're in the stasis break. And we simply just change the color of that background texture as we go. Really simple stuff. Really simple stuff. And to show you like the flexibility, you can kind of set it to be a rainbow, and that'll work. So if I unpause, there we go. So we're red, and then we go back in time, and we go through the whole rainbow. It's wonderful. So yeah, that's the basic gist of how the time reverse effect works. And the reason it looks visually interesting is because we also have a lot of stuff going on. So we've got these streaks that are happening, we've got the grid, and of course we have the enemies and the combat happening. And all these things together during the time warp kind of add up and all work together to make it a bit trippier. Well, we'll just set it back to what it was so we can look at the finalized effect just before we wrap up. So it's all that layering basically. The grid and the streaks are there to give visual interest even when there's no enemies on screen. And everything is just generally designed to kind of look good and pop during that effect. So that's Stasis Break. That's the effects breakdown. I hope that was useful. I hope you learned something. Maybe you can apply these things on your next Ludum Dare. These are pretty simple tricks. You know, some of them are a bit harder to use in different games, like for a first-person shooter or a 3D platformer, you could kind of struggle to use that depth clearing effect. It's doable, but it's a lot more work. But that's, you know, kind of the general gist. If you haven't played the game, I'll post a link in the description below. Give it a shot. I think it's a lot of fun. I'm really happy with how it turned out. It was a really good Ludum Dare. I've played a lot of great games. Thank you for watching. Later.